Okay, so now we're going to move on to the USB circuitry, which you can see right here, and it's pretty straightforward. This is a USB jack J6, and then we have a couple of resistors here, 22 ohm resistors here. This USB plus actually goes off to the microcontroller and is the supply coming from the USB. Now, you can't run this radio just from the power supply from the USB rail. You do have to have a supply voltage. And then the final thing of note is this PTR 5V0U2X IC, which is ESD protection circuitry. So it prevents static transients here coming through and damaging your microcontroller. Okay, so let's see where all this goes on the board here. So this is that ESD protection diode that goes right here. And then we have R5 and R4, which are the two 22 ohm resistors on the USB lines. And then we have R13 and R12. R13 is 100K, R12 is 10K, and that goes off to VBus on the IC here. Now finally, let's just pan down to the ESD protection diode itself, and here it is right here. So let me just zoom in a little bit so you can see that a bit better. So you can see here, here is that IC. So the two USB lines are IO1 and IO2, and they're at the top here. Then the big lead is ground, and then this lead here goes to VCC or VBus as it's mentioned on the diagram. So that's pretty straightforward. Obviously, it's pretty small, and I'll be using a hot air gun to get that on the circuit. Okay, so that's all on. Note the orientation of the ESD protection diode. This bottom right is ground, and that's where the big lug goes on the IC. The others, of course, are not polarized in any way. So what I can do now is get the USB jack on, and then we can come back and start some testing. Okay, so as you can see, the USB jack is installed. Let's plug this in and see what we see. So let's get the power side in. Let's turn it on. Okay, so solid green LED. And then let me plug the USB in. And you can see it's flashing there to indicate, I believe, success. I'm going to have to look up what that actually is. And then if we just go over to the computer that I've plugged it into, so this is a Linux box. Let me zoom in a bit, and then if I do an LS USB here, I should see that device there. And this is the actual device here. So Van Uyen Technische Information. So it's basically for use with lib USB. So that actually just proves that, let me just unplug it. I should see that device go away. Do USB, LS USB again, and that device has gone away. So plug it back in, and I should see it back there again. So that actually confirms that the USB device, that the laptop's actually seeing the USB device. What I'm going to move on to next is that there's some software that that comes with this Softrock software that actually allows you to change the frequency. So I'm going to, I've got that on my Windows PC. So I'm going to go over there, and we will have a look at that and see if we can affect the frequency that's being output by the SI570. Okay, so I haven't actually been able to get this working on Linux. I tried with Wine, but unfortunately I wasn't able to find a libUSB driver that works with Wine. So I've resorted to getting this running on Windows, and I've actually done this before. If you have a look back through earlier videos, the Ensemble RxTX uses a similar kind of set of software. And, you know, basically you have to use Zadig here to configure the USB drivers correctly. The instructions that are associated with the kit sort of go through in detail how you actually go about doing that. But the end result is you should see, bear with me, let me bring up the device manager here so you can see that. You should actually see underneath the lib USB Win32 devices, this Magnis right here. Now, there's a couple of pieces of test software that, so here's Zadig here, and you know, I'll kind of let you follow through the instructions there. But this piece of software here, the Config Softrock, allows you to actually drive the frequency output of the SI570 on the board. So you can see changing it, the instruction flows through the USB onto the board, and then we can have a look at the output on an oscilloscope. So Config Softrock, the links to that software is included in the documentation here. So what we'll do is just have a quick look at the test setup here, and then we'll see the output on the oscilloscope. Okay, so what I'm going to be doing here is in the Tune menu, you can change the desired frequency that the SI570 is emitting. Of course, you're actually instructing it to output 4 times that frequency because it goes through the dual D-type flip-flop arrangement, which produces the in quadrature signals. So let's have a quick look at the test setup here. So just panning down, excuse the shaky camera. So you can see I've got that plugged in both to the USB coming from my computer as well as to power there. And I'm probing those same points that we were looking at yesterday. That's pins 14 and 2 on, and this is the FST 3253 where the receive mix happens. So let's go over to the oscilloscope and check out the signals. Okay, so here you can see the 2 signals in quadrature. Up here on my Config Softrock, just let me pan around there. You can see it's configured to output 10.08 megahertz. And if you have a look on the oscilloscope, that's indeed what's coming out there. Now, there is a calibration function that you can run where you can adjust if you're kind of not getting exactly what you expect. You can adjust that. But let me just try and change the frequency here. So I'm going up in 1 megahertz increments. So now I'm at 12.08, 13, 14, 15, so on and so forth. Let's go down a bit now, just to confirm that. So now I'm down at 7.08 megahertz, and you can see there the output on the oscilloscope is exactly what we expect, which is to say 2 signals in quadrature at 7.08 megahertz. And then just finally, here is what the Zadig configuration should look like. So that driver up the top there is, it said in the instructions it was Multus SDR or something like that, but I'm not getting that. I'm just getting Magnis, and there's the driver configuration there, which is lib USB 0, 1.2.6 maps to lib USB-Win32. So, and then that USB ID down there, that's the vendor and product configuration that you should see for this particular configuration. So that's all I had planned to do in this video. It's a bit of relief that the USB side of things is all working. Obviously, if we had a firmware problem on here, that would be a bit of a pain to flash new firmware on it and blah, blah, blah. So, but anyway, so USB is all working. I'm able to control from the PC in this case, the frequency, frequency output by the synthesizer. I've been able to probe that at pins 14 and 2 of here. I've confirmed that it's all in quadrature. So good progress. What I'm going to move on to next in the build is the receiver side of things. So obviously that's where things start to get interesting. I'll put together the receiver circuitry, confirm that I'm getting the I and the Q signals out of that correctly. As I mentioned before, this board doesn't have any phase shift DSP processing on it. That's all done on the host computer. So what I'll have to do is hook it up to HD SDR. That's the software I'll be using on the computer to actually do the receiving. So anyway, that's to come in the next video. Hope you enjoyed this little one. That's all for now.